So we're gonna do the DevOps certification webinar today. So my name is Marcus Luga. I'm a trainer here at WebAge, and I am an Amazon authorized instructor, which means that I teach the Amazon curriculum. I'm certified to teach all Amazon curriculum courses. And I have recently, so back in September of 2018, I've passed my DevOps certification. So I'm sort of fresh out of the exam, and I'm able to answer any questions that you might have about the certification, about the exam, and everything that we have. So this presentation will sort of outline the details that you need to know about what parts of the AWS products you will have to look at in detail to be able to attempt to pass the DevOps certification. There are definitely benefits to passing the DevOps certification. There's visibility of your profile. So as soon as you pass the DevOps certification, you will definitely be approached by a lot of people in connection to that certification. It is also a benefit for your employer to have a person that is certified as a DevOps engineer. This demonstrates sort of that your ability to use tools in AWS to implement DevOps practices is valid. All right, let me just click through this slide because getting a little right. All right. So essentially, we're going to look at what the prerequisites for this exam are. So what you need to have before you even start considering taking this exam. We're going to look at DevOps and CI/CD practices that you need to be sort of aware of to be able to pass this exam. We're going to look at infrastructure as code. We're going to look at automation. Excuse me, this slide is going a little too fast. We're going to look at automation, and we're going to look at high availability, scalability, and resilience. We're also going to look at monitoring, logging, and troubleshooting of our application. And then we have some sample questions that we're going to look at that will give us an idea of what kind of questions you can expect in the exam. We have 10 sample questions, each from one of the knowledge domains. So the prerequisites, essentially, to be sort of eligible, or what is expected from a candidate that is attempting to pass the DevOps certification in AWS, is 2 years of experience with AWS, two years of maintaining systems, running applications. You should be aware of what the automation practices are. Excuse me, let me just pause for a second because I have an issue with this slide deck. Just a second. All right, so I apologize about this delay. The slide was advancing by itself, and that's not, yeah, the desktop sharing is disappeared, Jonathan, because I stopped it because I had to change my presentation. Sorry about that. So recommended knowledge for a typical candidate for this exam is 2 years experience with AWS. Essentially, you have to have the ability to maintain services and maintain applications in AWS. You have to be able to understand how the automation, the governance, and compliance principles can be implemented in AWS. Monitoring is definitely a prerequisite. So if you have knowledge of how to use monitoring to manage metrics, to manage logs, to stream out information into alerts, and then perform actions on those alerts, then of course you're the right type of candidate. The basics of AWS, like high availability, how to scale your applications, how to use self-healing in AWS, those are foundational practices that you need to know. And of course, managed services and foundational services, the difference between those, the shared security aspect of the environment, and of course, what your role in the shared security model is, and what the AWS's role in shared security model is. Of course, you're going to have to know those practices before even attempting to start learning about the DevOps part in AWS. So assuming that you already have these assuming that your knowledge covers all of these factors, we're going to look at the expected knowledge stack, right? So you should be familiar with the foundational services, essentially knowing everything about EC2 is pretty much crucial. So essentially looking at how do you deploy EC2 instances, how do you use compute services with EC2, what EC2 can perform, how you can do auto scaling, how you can combine your load balancers with EC2, how EC2 ties into VPCs, subnets networks that are running on top of regions, availability zones, what are edge locations and how you can use them, which services run in edge locations, right? So those are crucial factors. How to store your data, choosing the right type of storage for the right type of data, right? So we've got S3, EBS, Glacier, when those storage models are applicable. Your networking, your VPC, your elastic load balancers, your routing, your database services, all different kinds of database services, SQL, NoSQL, caching, and then of course Redshift as our data warehouse. These are prerequisites that you have to sort of know about before even attempting the DevOps track, right? So those, either if you don't have experience or you haven't had a course in those, you need to cover those completely. Get a real good footprint of knowledge of your AWS environment before you attempt the DevOps part. Then we have the content delivery services with CloudFront, right? Those run out of edge locations. Make sure that you understand how CloudFront operates and how you can use CloudFront to speed up your application and lower the cost of your application. Any kind of messaging inside of AWS, Cloud Search, you need to know about distributed computing with EMR and SWF, so software workflow and simple workflow and the Elastic MapReduce services. How to use libraries and SDKs, how to connect to those. If you have any knowledge with an actual programming language, a scripting language, those are definitely benefits in DevOps. And then of course, deployment and management tools, how to use the management console, complete basics, CloudFormation and Beanstalk, also OpsWorks here, right? How they differentiate. You're also going to be looking at all the code tools, code deployed, code commit, and we're going to look at those in our presentation today. And then of course, how to work with IAM and how to use monitoring in CloudWatch. Those are sort of crucial areas that need to be covered in this exam. On top of those, we're going to look at some more details in our presentation today to show you what other features we're going to be looking at. So essentially, to prepare for the exam, there's a few steps you can take, right? First, training. You can take AWS training. WebAge is now a Amazon training provider, so we provide the full curriculum of AWS training courses. We're going to start with a public schedule of training courses, I think in June or July timeframe, something like that. If AWS training is not enough, well, it is not enough for passing the exam, for sure. It shows you the areas, gives you the basics, but hands-on is probably the best thing that will help you pass the exam. If you want to go deeper into services that you're unsure of, AWS white papers, there are certain white papers for each exam, and if you look in the exam blueprint, you will get the exact list of the exam of the white papers that apply to this exam. You got hands-on labs, so you got free labs that you can use on AWS. Open an account, go to those labs, run those labs. You got exam prep books. A lot of different publishers have exam prep books that will help you go into a lot of detail and pass that exam with the greatest of ease. And of course, sample questions. Some of those books will also include sample questions, whereas sometimes sample questions, you can source them also online for different preparation cycles that you're doing. So for example, if you're getting to know the technology, go to the training, go read the white papers. If you're looking for more hands-on, run the hands-on labs and then experiment as much as you can. And when you're at the stage that you're going to go for the exam, take an exam prep book, pick up some sample questions, go through those sample questions so that you can see what the structure of the questions and what you have to expect on this exam. Essentially, the AWS exams are one of the most difficult exams as far as the industry exams are concerned. Now let's focus on DevOps. So basically what we need to do is we need to understand the DevOps cycle. We need to make sure that we understand how the DevOps cycle aligns with the CI/CD goals. Those essentially are going to help us understand the difference between what CI/CD is, what DevOps is, and what being agile is, right? So that is sort of the basic element. Sometimes we use CI/CD completely interchangeably with DevOps, right? Because the goals of CI/CD, of DevOps, and of Agile really align well, right? DevOps is focused on the culture. DevOps is focused on building a culture of essentially responsive teams that will able to take ownership of an application and lead that application through all the cycles of DevOps, right? CI/CD is the tool set that is very suitable for DevOps because it is designed for very automated, short iterations, quick iterations, and it's focused on building your tools, using the tools to implement the continuous integration, continuous delivery, continuous monitoring, continuous reaction, all of those features into your DevOps cycle. And Agile is sort of a process or a business practice that essentially is highlighting the change of moving from a rigid enterprise into a dynamic system, and it focuses on accelerating delivery of the results, right? So the results from a developer standpoint of view completely align with what DevOps is all about. It's about being responsive to the needs of the clients, and Agile is also about that. And CI/CD sort of helps us pull all that together and implement the tool stack. So the continuous integration practice essentially is a practice of merging code frequently into a repository and then performing actions on top of that repository. So you need to have a shared code repository. You need to create automation of testing of your code. Automation of testing will help you determine whether that code is running correctly, and of course, whether it can be then passed on into different build stages. You've got the test build stage, you've got the staging build stage, quality assurance, etc., right? Down to, of course, the production stage. Continuous integration is all about having similar environments where you can run development, testing, deployment into similar environments so that you have reliability. And of course, any tests that were run need to have a visible result on the dashboard itself. So for the CI part of CI/CD, we can use code commit in AWS. It's a fully managed repository that is completely Git compatible. So you use standard Git commands. Basically, having developers use code commit is like having developers use Git. You can use public or private, you can build public or private repositories, and everything that is stored into the environment is secure with automatic encryption, so all the data is encrypted. The service is highly available. It's a fully managed service. You don't need to take care of any servers. You don't need to take care of any features on that environment. And it supports automatic triggers that can trigger anything out of that environment. On top of code commit, we can use code build. It's a tool for building your source code into actual packages, into operational packages that can then be installed onto operating systems. So essentially, the pipeline for this is whenever any code hits the code commit service, it can automatically trigger code build processes, and then code build processes output that code into a certain next stage, whether they store it onto a certain repository or certain bucket, S3 bucket, or whether they push it on into further stages of testing and reinstallation on other environments. Everything within code build is automatically encrypted, so all communication is HTTPS, so it is encrypted, and anything at rest in code build is encrypted. Essentially, code build spins up building environments, and those building environments spin up on demand while those services spin up. They are connected to the code build environment, and then code build transfers the packages onto those environments, and they perform the build and output the results to wherever. So essentially, we're only paying for running builds. Whenever we have an EC2 instance that starts up and we run that EC2 instance, we're only going to be paying for that. So it's really, really useful whenever you don't want to have an environment that's sitting there all the time. Whenever you have very infrequent builds, whenever you have unpredictable build volumes, right? You could have volumes that scale from 1 time to 10 times during the week, right? And because of that unpredictable scale, code build really offers you a great benefit over having your own build server or build environment where you have to manually scale it, you have to manually run it, and you have to manually terminate it if you don't need it anymore. So what do we go for? Either continuous deployment or continuous delivery, right? There's 2 aspects of the CD factor in CI/CD. So whenever we want to talk about just getting the packages out and making sure that the package is released, then it's continuous delivery. Whenever we want to talk about deploying the application to an actual stage, like for example, production, staging, etc., then it's continuous deployment, right? So continuous deployment will require full automation, whereas continuous delivery is going to be a good solution when we don't have control over the production system. If we're building software that clients install themselves, then continuous delivery is basically the only option we have, unless we allow clients to permit us to automatically update their system whenever changes occur. So continuous delivery essentially is building, testing, and releasing the software, right? It releases the software onto a repository, and then the users can come along and pull that software and install, right? The dependency of updates will be completely dependent on the user, so how frequently they want to update, or what their policy is for updates, or how they test their updates, right? For example, continuous deployment, it is actually delivering the software through automated deployments, whether it's delivering into production or delivering into a staging environment where additional approval can happen. It's still continuous deployment, right? So any package that is created is automatically going to go through an automated approval of deployment, and if it passes the automated of approval, then of course it can be deployed to staging, it can be deployed to production, etc. With continuous deployment, we can have a very, very fast update frequency. We can do updates and deployments multiple times a day. And that's what businesses are now striving to, essentially because of the needs of users to have the most recent, the most updated fixed system. And of course, because we want to deliver new features in the fastest manner possible. It's also a security aspect, right? With a continuous deployment that happens multiple times a day, we can squash 0-day bugs on day 0, right? That is a really, really big benefit of continuous deployment. For CD, we can use code deploy. So it automates software deployments, and it allows us to completely manage our deployments from a centralized repository. It requires a running environment, right? So it integrates with other tools, for example, CloudFormation, which we'll cover later, to build the infrastructure. And once the infrastructure is built, it can take those instances and deploy software on them. It has the ability to track the versions that it has deployed, so it's pretty smart as a tool. To be able to automate our environment, we're going to need to introduce infrastructure as a code. Now, what is infrastructure as a code? Essentially, it's maintaining your environment through a scripted manner, right? Making sure that all your infrastructure that you are deploying happens in a completely scripted manner. By doing infrastructure as code, you can stop thinking about servers and start thinking about services, right? I need a service that will perform a response on a certain web address. And you can script that as a service. You can use a container, you can use a server, or you can use just a function with a front end to perform that action, right? It's not necessarily a server anymore. Infrastructure as code allows you to store your code with your application. So when you are doing the deployment, you can push the infrastructure as code into the environment, and that builds half of the environment. And then once you've got the environment running, a bare environment with no application, you can run configuration management or code build on top, and that can actually install the application and build your environment, the other half of your environment. So having infrastructure as code allows you to do repeatable, very reliable environments. You can test the infrastructure as code documents in the same manner that you would test your code. So that's something that's really important, and you can combine it with your CI/CD tools to build the environment and thus increase the reliability of your environment. So traditionally, what we would do is we would have to spec and source the hardware to install the hardware once it's delivered, connect it to the SAN, to the power, to the network, install the operating system, and then install the software, right? We then test on a small scale and never be able to test at production scale because we'd have to have double the capacity, right, to test at production scale. The delivery times for the traditional approach are days to weeks, possibly months, right? With an infrastructure as code approach, what we have is we just write the specification document. We store that specification document on a repository. We can test that specification document at production scale, right? We have the ability to say, okay, my production has 100 servers. I want to test the performance of my application on 100 servers in parallel with the production. With infrastructure as code, what you can do is you can spin up that 100 servers for a temporary amount of time in parallel with your production, run the testing tools on them, and it will cost you a fraction of the cost of running your application. So for example, if you run your production of 100 servers 24/7 over a year, then running one day full-scale test will cost 1/356th of a full cost of your application, right? Whereas a typical traditional environment will have 10 to 20% of hardware dedicated to the testing. You'll never be able to test at full scale, and you have to have a capital investment that's 10 or 20% more than what your application requires just to provide room for testing. And once you got the test done at production scale, you'll be much more confident that you can deploy your code to production. You can deploy the changes in the infrastructure, and you can deploy the software with an infrastructure as code approach. Automation. So next step is automating all those together, right? Making sure that a trigger coming in from one environment can trigger another environment, can trigger another environment, and can trigger the deployment, right? So essentially, when we're looking at automation, we're looking to remove the human factor. We're animals that make mistakes, right? Machines, they tend not to make mistakes, so they're better at repeatable tasks. Tasks that can be scripted, tasks that need to be run over and over and over again. So what we're doing with our deployments of our application, we're doing that deployment over and over and over again. We're deploying the infrastructure over and over again in development, in test, in staging, in QA, in production, etc., right? And we're also deploying the application once a day, once a week. It's over and over and over again doing the same process, right? So DevOps teams should be focusing on innovation, should be focusing on coming up with new ideas, writing code, doing what humans are good at, being agile, being flexible, responding to user requests, whereas the machines should be doing those repeatable actions. We should also make sure that all the processes and tasks of a CI/CD process should be as automated as possible. You want to have as little manual intervention with your CI/CD process. That will make it much more reliable and much faster. Because if somebody forgets to make to take the manual step. If somebody misses a step, excuse me, on their checklist, then of course you might be bringing in errors into the deployment, into the testing, etc. And the next step after CI/CD, you've got automation of monitoring and automation of response. With AWS, you can use the tools that are built into the environment to provide the ability to perform automated actions. When you receive a certain kind of metric, you can scale your application. When you receive a certain kind of log entry that says error this, error that, you can stream those logs into your CloudWatch environment and continuously monitor that with a certain function. That function, once it receives a log with a certain error, can respond in an intelligent way, and some kind of action to remediate that error can be triggered. So that is the benefit of a CI/CD practice inside of AWS. As I've already mentioned several times, CloudFormation is your infrastructure as service orchestration tool. It is the perfect solution when you're implementing infrastructure as code. With CloudFormation, you write a JSON or YAML specification document and you store them in S3. You also have built-in versioning with change sets. Change sets essentially allow you to create changes, overview what the change will do by running a command to check the changes, either in the command line or looking at the infrastructure in the management console. And then once you're happy with the changes, you can execute those changes in CloudFormation, which is a really, really good option. Next, we've got OpsWorks. So OpsWorks is a configuration management service. It is a completely managed service that lets you build 3 different types of servers. So you got OpsWorks Stacks. This one runs Chef 11 or 12. It allows you to control any instances on your environment, any EC2 instances on your environment, in your account or in multiple accounts. It allows you to manage any servers that you have on premises, and it allows you to manage layers of different services like load balancers, like databases, like message queues, etc., that are attached to your application through one unified interface. It's really easy to get started with, and it has no additional cost unless you're running any agents on any on-premises servers. Those have an hourly usage cost that, of course, cannot be avoided. And then we have 2 tools. If you have an environment with Chef Automation or with Puppet Enterprise, OpsWorks can deliver a fully managed Chef Automation or a fully managed Puppet Enterprise server. So those are for businesses that already use those configuration management tools and would like to port those into AWS. They integrate really well with Code Pipeline so that you can build your infrastructure and modify your applications when you're deploying the software through those tools. We also have Elastic Beanstalk. Now this one is built for simplicity. It's a platform as a service. So basically you specify what kind of platform you need for what kind of code. All you need to know is your code and your version of your code. And you specify that. You tell the service whether you need a database, whether you need some kind of storage for your static content, etc. And the service will automatically create all the resources required in AWS. It will build the EC2 instances. It will spin up your application on top of the EC2 instances. It will connect those EC2 instances to databases, message queues, any static storage. It can build load balancers, and it's really, really useful. It comes at no additional cost. So essentially, you have the ability to use Elastic Beanstalk, and it will deploy your resources, and you will pay only for those resources that it deployed. So for example, if you did it through Elastic Beanstalk or if you did it manually, it costs exactly the same. All right. So which tool do you want to choose when you're doing deployment and management, right? So if you want complete simplicity, you should be looking at Elastic Beanstalk. If you're already in Chef or Puppet, then OpsWorks is a good solution. When you want to do it the standard Tosca compatible way, so Tosca is the topology and orchestration standard for cloud applications, If you're using a Tosca tool already, then migrating to CloudFormation in YAML or in JSON will be pretty easy. And CloudFormation is really designed for infrastructure itself and infrastructure as code. And of course, you can also go to do it by yourself, scripting, right? Poor man's automation, as we call it. When you're going for the exam, make sure you understand the differences between Beanstalk, OpsWorks, CloudFormation, right? Those are critical differences that you need to understand, and of course, any costs that they bring. So you're gonna have a question like, what is the most cost-efficient way of doing things? And then going to be three answers. One is going to be use Elastic Beanstalk. The second is going to be use OpsWorks. The third is going to be use CloudFormation, right? It definitely will make a difference if you understand the costs themselves also. To automate your CI/CD process, you can use Code Pipeline. So it's a continuous delivery service. It is designed to completely automate all the release pipelines. It's designed for rapid delivery of software, and it's really, really easy to model the release itself because it is designed in the graphical user interface in the management console. So with Code Pipeline, what you can do is you can create multiple deploy stages, you can create multiple testing stages, and you can control how your packages transitions from one stage to another. So you'll always have some kind of trigger for Code Pipeline. So for example, a trigger can be a commit to a repository. So for example, you're committing code to code commit, or you're committing code to some kind of Git repository that is connected to your Code Pipeline. That can be your trigger to run a CI build process on your code build environment, or if you've integrated your Jenkins server into your environment, or Gradle or any other tool that can do building of the code. And then once the code is built, Code Pipeline will take the outputs of each of those operations and push them into further stages, like, for example, deployment to staging, deployment to production, and perform additional testing on top of that. So it is a really, really useful tool. Okay, let's go. Come on. All right. I'm going to pause here because we have a question. Ram says, my DevOps professional certification is expiring in November 2019. Do I have time to take this exam until November 2020, or do I have to take the exam before November 2019? There is a grace period, and I think it is 6 months after your certificate has expired. So that grace period means that you won't be certified in that time, but once you take the exam, you will recertify. You can take the recertification exam type. So there's two types of DevOps exams that you can book. One is a recertification, and the recertification will be only available until the grace period expires. If you do not have that recertification, then of course, if you don't take the recertification, you will have to go for the complete full exam. It could be that they extended it to a year. I remember 6 months somehow, but it could be a year. I can check that at the end of this presentation for you. All right, as I said, any questions, just answer them, write them into the Q&A section, and I will pick them up as soon as they come in. What do we need to know about high availability, scalability, resilience? Well, we're going to need to know how to choose a region and why you want to choose a certain region. And of course, what kind of availability is built into each service that you have, right? So those are really basics, but they sort of go and extrapolate into all the advanced stages of your environment, right? How do we do scaling of our application? What kind of services support auto-scaling services? How do auto-scaling services even work? How does auto-scaling integrate with the metrics, and how do the metrics go to the auto-scaling service? Those are good questions to look at, and you're going to have to sort of get a good understanding and a good baseline for those. So which of these services are highly available by default, right? Your stack that we looked at, which of those are highly available? Well, there are some services that are highly available by default, right? So for example, DynamoDB, highly available, highly scalable by default. All we need to do is set a key for our data and then start storing that data, right? Nothing to do about high availability. Elastic Load Balancer, not much to do about high availability there. If you do have traffic that will go beyond one unit of ELB, you can talk to AWS and they will help you pre-warm new instances. Route 53, no scalability issues there. It's highly available. It runs from all the edge locations, and it is the only service that has 100% SLA. Storage high availability. Now, all of these services are highly available, but some of them are also highly resilient. So what's the difference between availability and resilience? Well, availability is it can survive a hardware failure. Resilience is it can survive a major outage, right? So for example, S3, that one can survive a complete outage of a complete availability zone. Your data will survive. Elastic Block Storage, that one will survive a failure within the availability zone. Everything is replicated. It will survive a failure of a disk, but if a whole availability zone goes down, your availability, your Elastic Block Storage volume can disappear alongside that tool. Your SQSQ, your SNS service, those are highly available by default. Nothing to configure there. Your management console, your CloudFront, those are also highly available. But with EC2, with the VPC, with the EMR, how do we make those services highly available? Those are sort of questions that will be asked in the exam itself. What do we need to know about monitoring, logging, and troubleshooting? Well, know your CloudWatch, right? Get deep into CloudWatch and understand what you can measure, what kind of metrics are in CloudWatch, detailed metrics and standard metrics, how those two compare, what kind of custom metrics you can enter into the CloudWatch environment, and what you can do with custom metrics, right? How do you create alarms and actions on top of CloudWatch, and what kind of AWS services you can integrate CloudWatch with. So for example, autoscaling, Lambda, you can integrate with other services can perform intelligent actions. CloudTrail, what is it? It's an integrated access logging service. It logs all API calls to AWS and helps you create alarms and actions if a certain event type happens. And of course, it integrates with AWS services to prevent any kind of unauthorized access. AWS Config, it is a state tracking tool, so it allows detection of changes, and of course, it allows you to automate actions on top of that. You can take environment snapshots, and you have to understand how you can use AWS Config for security. So the combination of CloudWatch, CloudTrail, and AWS Config is your complete environment security module. Why are we talking about security? This is DevOps. Well, what is your application if it isn't secure? Well, it's nothing, right? All the bugs, all the issues, all the patches that are required, everything is introduced through code that is not written well, that has skipped some security testing in the DevOps process. So if you're truly a DevOps engineer, then you will be focused on security as much as you're focused on your Jenkins server or your CI process or your practice or culture that you're building, right? Security shouldn't even be a consideration where we're saying now, oh, DevSecOps is the next step of DevOps. No, DevSecOps should always be in DevOps. That should be an integral part of DevOps. So essentially, that's why we need to know these tools, because we're going to be expected to know how to build environments that are also secure, not just agile, not just developed in a fast and efficient manner. AWS Trusted Advisor, what does it do? What the features are? How can it help you to run those automated checks for cost, for security, for fault tolerance, for performance, and for service overutilization or limits? How do we do troubleshooting in DevOps, right? What do we do when a service is not responding? An EC2 instance is not responding. What do we do, right? Well, as a DevOps engineer, you're going to have to know that. right? You're going to have to know that if an EC2 instance is not responding, you either have a security rule problem, you've got a problem with the instance operating system, reconfigure that instance, or terminate and restart, right? Error 500, error 400 and 500. How do we respond to an error 400 or 500? Where 400 is usually we're unauthorized or we're hitting the service with some kind of request that it cannot respond to. Error 500, we're hitting the service limit. Service and provisions at the appropriate level, or there's other issues. For example, we're hitting a certain limitation inside of the service itself, or it's throttling us, right? What is the proper approach for 400 errors? Well, we have to fix it in the application. What is the proper approach for 500 errors? It's back off, right? Backing off and retrying your queries in an exponentially longer time. Data retention, data recovery, backups, how to stream your data, right? Those are crucial. How long is the data retained on a certain environment? How long is the data retained in your certain service, right? What is the data recovery procedure for a certain service? How can you perform backups of your environment? How can you perform capturing and processing of streaming data? And of course, using CloudWatch, CloudTrail, config, VPC flow logs to troubleshoot your environment, right? Those are definitely going to be a part of the questions that are in the exam itself. Know your service limits. When are you exceeding your service limits? How many files, what's the file size for maximum file size for S3? How many messages per second can you send into a FIFO queue, right? Those are questions from the developer exam, but of course, DevOps has to integrate a part of developing, so you have to know your service limits. When do you contact support? What steps do you have to take to contact support? Right, so what does the exam look like? You got 80 multiple choice questions and multiple answer questions. So you're going to either select one answer or select multiple answers at a time. You have 170 minutes. So you have about 2 minutes per question on the exam, right? That might seem like a long time, but questions can be quite complex and quite long. So you shouldn't be trying to answer each and every question in a sequence. If you can't answer a question, mark it for review and answer as many other questions as you can. Try to answer the fastest questions first, the ones that you know the response out of the box, and then mark the others for review. Go back when you're at the end and try to answer them, right? A lot of people who have attempted the DevOps exam and failed have failed because they got stuck on a question and they got to 60 questions, and that's a fail, right? You fail, you don't fill out 20 questions and you fail one more, you're definitely failing, right? The question score is variable. So you have 80 questions and all those questions amount to 1,000 points, right? Each question has a certain number of points, and of course, all the questions are scored in full. So if it's a multiple answer question and you get 3 answers right and 1 answer wrong, you get 0 points. There's no half points, right? And the multiple answer questions are the ones that are the most difficult and have the highest score. So make sure you're focusing on the multiple answer questions. Passing score for this exam is 750 out of 1,000. That might mean you're going to answer 70% of your questions, right? And still get 750 points because you might be answering the difficult questions. Or that might mean you're going to be answering 80% of your questions, but they're all going to be the easy ones, right? And you're going to be below 750. So there's no percentage of correct answers. There's only the passing score of a certain number. What I like to say is your confidence for the questions has to be above 80%, probably at 85 or 90%. So if you go for a test exam and you pass with 85, 90%, then you're probably going to be passing the DevOps certification. All right. With about 12 minutes to go, we're going to look at 10 sample questions. So first question comes out of the main one, continuous delivery and process automation. So question is, part of your CI/CD process is designed to test the application performance on AWS. Your EC2 instances use M5 large type, Amazon Linux AMI, and EBS volume with 3,000 IOPS reserved. 100 instances are deployed from a snapshot that is created at the last stage of the install, simulating production scale. The tests are delivering poor results, and you are tasked with determining why. Answers are, to get maximum CPU performance during the test, your instance type should be M5 extra large. Well, I don't want to use an M5 extra large, so that is a bogus answer, right? I want to use M5 large types. And we're missing one of the answers. Okay, let me try and fix this. Whoops, there we go. Why are we missing one of the answers? That's not good. Okay, let me just get this done. Let's do this. Return back to the question, and it does not help. Okay. All right. Just a second here. Let's try something else. I will be right with you. And here we go. Okay. All right, let me just share this thing here. All right. Let's just share this one. And we need to jump to the slide that we were at the end. All right, this is the one. All right, so to get the maximum CPU performance, use the instance type M5 extra large. That's not a sensible question. I want to use M5 large, right? So we're going to eliminate that one. To get the maximum IOPS performance during the test, the disk should be pre-warmed. That's an interesting answer. To get the maximum RAM performance during the test, RAM should be pre-warmed. There's no such thing as pre-warming the RAM, right? So that is complete nonsense. And deploying 100 instances from one snapshot is decreasing the performance. Well, the appropriate question is, we need to warm up the disk because any disk deployed from a certain volume need to be warmed up. All right, your application consists of most agile and cost-effective approach to build a CI/CD stack for this application. Use Upwork stacks to deploy the application as layers in one stack. Is that going to be agile? Well, maybe, not necessarily. Is that going to be a cost-effective approach? It might be if you're very happy with working with Chef. Second one, manually create the VPC and deploy Elastic Beanstalk application on top. That's not really a good option, is it? Whoops, that slide shouldn't have gone forward. Come on. Again, slides should not be advancing here. Apologize. Just a second. There we go. And there we go. Let me just share this back. and we should be there we go. All right, so question number 2. Your application consists of multiple tiers. Yeah, we said so. Manually create the VPC and deploy Elastic Beanstalk. We don't want to be manually creating anything because we want to be agile. We want to build in a CI/CD approach, right? Use CloudFormation stacks to deploy all the services in several different stacks. Provide outputs from the previous stack to the next one, or use a single CloudFormation template to deploy all the application layers as one stack. The most agile way to do it would be to use several different CloudFormation templates, and that will be the answer here. High availability and elasticity, domain 2. You're deploying a web front end on EC2 behind a load balancer. You're using an instance type with an ephemeral volume. What would be the best way to ensure Apache logs are not lost if the instance is stopped or terminated? So if we're storing a log on an ephemeral volume and we terminate the instance or the instance is lost, that log will be gone, right? So what we can do is, it says store the log on a separate EBS volume of 1 GB. That could be a good way to store logs, but we're looking for the best way to store logs, right? Use CloudWatch log agents and stream the logs to CloudWatch. That's a good way to store our logs. Let's see what the next one is. Copy the Apache log files every second to S3. The file is small and will barely cost anything on S3, but if we copy every second, then we're going to be running into 80,000 and some more put operations on S3, and that's going to be very costly, so that's not a good option. And then perform a frequent snapshot of the ephemeral volume. Again, that's not a good option because we can still lose quite a lot of data while that snapshot is creating. So we're going to either have to choose an EBS volume or CloudWatch logs agent. EBS volume might get filled up. There might be more than 1 GB of logs, right? Whereas CloudWatch logs is going to be the most efficient way of doing things here. Right. Question number 4, high availability and elasticity. Your application runs on an EC2 autoscaling group configured to add 1 instance when group CPU utilization is above 75% for 10 minutes, and remove 1 instance when the utilization is below 25% for 10 minutes. Your instances have scaled out to the maximum number even when the usage goes below 75%. What could be the cause of this? The answers here are: the CloudWatch agent on the instances is not reporting CPU usage to autoscaling. Is that a possibility? You're using the wrong trigger. Replace the CPU metrics with network utilization. But I don't want to. I want to use CPU utilization, right? The scaling policy is incorrectly set. Is it incorrectly set? The CPU usage is not a good trigger for scaling, as it is not predictable. Well, we don't need to predict usage. We just want to have thresholds above each and every one of them, right? So question A or C. A says CloudWatch agent on the instance is not reporting CPU usage to the autoscaling. CPU usage is collected from the hypervisor. So essentially, that leaves us with the policy being incorrectly set. Why do we think that the policy is incorrectly set? Well, essentially, the policy itself says I want to scale above 75%, but then I want to scale down, scale out, scale in when I'm removing my instances below 25%. So my application probably has never reached below 25%, so it's sitting there at 40%, and it's not scaling low enough to trigger the downscaling, to the removal of instances. So basically, if I set that utilization below, for example, 50% for 10 minutes, then that might actually be better. Scaling policy is incorrectly set is the correct answer. Question number 5, cost saving practices. Your management has reported a 25% increase in the monthly bill. You review the bill and determine that the cause of it is an increase in the data transfer cost. How can you break down the data transfer cost to determine which application is responsible for the cost increase? That is an interesting one. So how do we figure out which application is responsible for the cost increase? We might be running multiple applications in multiple groups of servers. So how do we do that? Answer 1, increase CloudWatch metrics granularity from 5 minutes to 1 minute. That will not give us information about the actual instance, will it? Or actual application that's running up the costs. Run EMR on CloudWatch logs. So that's Elastic MapReduce cluster. Take CloudWatch logs and then MapReduce the logs to get the top 10 usage, right? Do we even have any CloudWatch logs? Is this application sending information into CloudWatch logs is the question. There's nothing in the description saying that you are storing the logs for the application in CloudWatch logs. Number 3, use custom metrics from your application to break down the costs to more specific application level metrics. That could be a reasonable answer. You could take the metrics from your application and input those into CloudWatch logs and then introduce those metrics into your billing report as sort of a note to see who has been consuming that bandwidth. And number 4, use ELB CloudWatch outbound data transfer metrics to determine the application that is causing the traffic costs. That could be a possible option, but you could have different applications behind an ALB. So I would say number 3, use custom metrics for your application to break down the cost to more specific application level metrics, and that will help you determine the usage. Question number 6. You have EC2 instances in a private network that need access to S3. The instances will be transferring more than 10 terabytes per day to and from S3. Choose the most effective solution, cost-effective solution for this setup. 3 different options, using a VPC endpoint for S3 to connect to a private endpoint, using a NAT gateway in the public subnet and connect the S3 public endpoint, using a VPN instance in the public subnet to connect to the S3 public environment, and directly connect to S3 as there is no cost associated with transfer between S3 and EC2. Now, the second part of answer D is correct. There is no cost associated between S3 and EC2, but we are in a private network. So there is a private network, so there's no direct connection between a private network and an S3 endpoint because all the S3 endpoints are public. Using a NAT gateway would introduce transfer costs on the NAT gateway, and a VPN instance does not make any sense because we cannot connect a VPN to S3 to an S3 public endpoint. So the only option is using a VPC endpoint. That will not introduce any data transfer pricing, and it will introduce a private endpoint for our S3 service. All right. Question number 7. Your application stores sensitive information on an EBS volume running on an EC2 instance, on a running EC2 instance, actually. How can you protect the data with encryption while protecting the data integrity? So there's 2 questions. We want encryption, and we want to make sure the data integrity doesn't get broken while we're doing encryption. Now choose all that apply. Answer 1, stop the instance, take a snapshot of the volume. That's a reasonable answer. Answer number 2, once the snapshot is created, turn the EBS volume to an encrypted volume with the AWS EBS encrypt volume command. Well, the first thing is a snapshot and the volume do not have anything in common, so why would you make a snapshot before you run a command on a volume? Maybe for a backup, but really no reason to do that. And the second part of this answer is there is nothing like an AWS EBS encrypt volume command, even though it sounds really good. Number 3, while the instance is running, take a snapshot of the volume. Well, if we want data integrity, then it's better to stop the instance, right? While the instance is running, I can take a snapshot of the volume, but my instance could still be writing to that volume. So if I want data integrity on the encrypted volume, then I need to stop the instance for sure. So answer A definitely applies. Answer D, from the snapshot, create an encrypted snapshot copy, deploy a new volume from the encrypted snapshot. That is going to be a correct answer because that's the only way to encrypt a volume is create a snapshot, create an encrypted copy of that snapshot, and then deploy a volume from the encrypted snapshot. And then answers E and F, delete an unencrypted snapshot and delete the unencrypted volume, both apply. So for all of these four, A, D, E, and F are going to apply for this part. Question number 8. We've got, we're in charge of infrastructure and compliance. We need to build a tool that will notify the incident response team if anybody assumes the administrative role in an unscheduled manner and automatically disable the temporary credentials. Which services will help you achieve the task? A bunch of code names. SNS, CloudTrail, and Lambda, SQS config and CloudTrail, CloudTrail config and IAM, SNS, CloudTrail, and IAM. So what do we need to do? We need to notify somebody, right? That points to SNS. So we're going to need SNS, and we're going to need to have an incident response when somebody assumes an IAM role. How can we trail API calls like a role assumption? Well, we need CloudTrail to do that, right? So SNS and CloudTrail are needed. So B and C are answers that are there for distraction. What do we also want to do? We want to automatically disable the temporary credentials that were issued to that role, right? So how can we do that? Can we do that using IAM? We can, but we need to log in to the management console, use IAM, and then, well, actually, we would have to do it through the command line. So script it through the command line, but we can automate that to automatically disable with a Lambda, right? So we can write that command into Lambda, and the answer is going to be A. Question number 9, monitoring, metrics, and logging. You are running an application on EC2 that's not performing well. You look at the CloudWatch metrics and you find the instance is using a lot of disk I/O, even when there is a little traffic to that instance. In the operating system, you discover the instance is swapping due to lack of memory. So how can you ensure you're alerted when the memory utilization is above 90% of the instance? So we got an EC2 instance, and we want to be alerted when the memory utilization is above 90%. For 4 answers, create a trigger to notify you when the memory metric on CloudWatch is at 90%. Create a trigger to notify you when the disk usage on CloudWatch is high. That doesn't make sense. We want 90%, right? Add a custom metric to CloudWatch for the memory usage and create an alert at 90%. Add a custom metric to CloudWatch for swap usage and create an alert. Now, the only 2 answers with the 90% are either we're going to use the memory metric from CloudWatch or we're going to use a custom metric in CloudWatch. Well, for EC2, there is no such thing as a memory metric, so we need to create a custom CloudWatch metric and create an alert at 90%. And question number 10, which brings us a little bit over what our time was projected for this training, probably because of the issues that we had with our presentation, but we mitigate everything. Domain 5, monitoring and metrics and logging. You are monitoring a multi-tier auto-scaled application behind the load balancer. The application becomes very slow for 2 to 3 minutes at a time, but then suddenly recovers. You analyze the CloudWatch metrics and the application logs and find that there is no apparent issue with the application. What possible approaches could you take to analyze the performance of the application in a better way? Select all that apply. So we got a multi-tier auto-scaled application. It becomes slow for 2 or 3 minutes at a time and then suddenly recovers, right? Answer number 1, set the metric collection on your services to debugging. Is that going to do anything? Probably not, because there's no such thing as a debugging metric collection. Set the metrics collection interval on your service is too detailed. That will bring our metrics collection from 5 minutes down to 1 minute. It's a service that we pay for, but since we are debugging, that makes sense because we want to see what's happening with the performance during those 2 to 3 minutes when the application becomes slow. Number 3, use CloudWatch Agent to deliver custom metrics from the application. Use CloudWatch Agent to deliver debugging logs from the application, and use Trusted Advisor performance checks. I would definitely say CloudWatch Agent to deliver custom metrics from the application would be one possible option. And a third one, use Trusted Advisor performance checks. But Trusted Advisor has very standard performance checks, and it will not be able to analyze at the short detail that we have here, 2 to 3 minutes at a time. So the answer is B and D. B and C, yeah, custom metrics and collection of the information. Right, upcoming classes. There's a TP 2771. It's the DevOps Certification Bootcamp Professional. So we do offer a bootcamp for this training if you want to get sort of from zero to hero, skip some of those length of usage requirements at AWS. We can give you detailed labs that will help you sort of become certified in a much faster way. We also have a new service machine learning, new course machine learning on AWS. It's really cool. So if you want to see those, go to webedgesolutions.com/courses/AWS-training, and you will see all of those courses in there. And of course, questions. One more question from Ram. Will there a huge difference between the 2017 exam and 2020 exam? Unless there are huge differences in DevOps itself, I would say no. The professional exams are pretty tough exams. They are built with the sort of trying to trick you in mind as much as they can. If you have taken the 2017 exam, you will see the differences in the services that are being covered. So all the services that are new since sort of 2018 will be covered in the 2020 exam. So there's probably going to be more automation stuff, more of the pipeline stuff, etc. Any other questions at this point? All right. So I'm sharing the presentation again in the chat box. You've got the presentation here. And yeah, if you are interested in passing the exam, reach out to WebEdge. We can help you sort out your certification path. If you have companies if you're working for a business that is sort of trying to implement a certification path for all their newcomers, for all their fresh out of college hires, we specialize in those. We build boot camps, we build sort of hackathons, project-based trainings where we give a training and then a project that takes a few days, and then the students can come back with a project. A really cool new thing that we're doing now is hackathons, where there's the 4 hours of a standard course, and then there's another 4 hours of the hackathon every day, and you can perform much better after the training because you got all the fresh knowledge that you've just used. You can implement it into that solution. Otherwise, if there are no more questions, I will say thank you very much for attending this webinar. I hope you got a little bit of an overview what's at stake when trying to take the AWS DevOps Professional Certification exam. That is it from me, and I will keep this session open for another 10 minutes if anybody has any more questions or if anything comes up. Yes, the deck is shared. The chat has the certification. I've just answered your question with the link. The link for this slide deck is in the chat window. So if you open the chat window, you will see it, and it's also in one of the answered Q&As. All right. Thank you very much for joining. I will stick around for a few more minutes just in case anybody has any questions or anything else comes up. You are welcome.